slope-intercept form. We should be good and familiar with that at this point. So now let's introduce a new formula called point-slope-form. So slope-intercept form, we needed to know the slope and we needed to know the intercept, right? What do you guys think we'll need to know for this form? A point and the slope. And well, the form is the formula itself. All we need to know is a point on the line and the slope of the line to be able to write an equation in point-slope form. Here's what point-slope form looks like. Y minus y sub 1. So a little underneath exponent as we talked about with the slope formula. Subscript, yep. Is equal to m times the quantity of x minus x sub 1. My least favorite formula, point-slope form. I don't have a fun way to remember this one, so it's up to you. X1, Christian. Okay, in this formula, m represents the slope of the line, obviously. And x1 comma y1 represents a point on the line. It doesn't matter what point. You can pick any point. The coordinates x1 comma y1 represent a point on the line. Christian?
What's that on, like, on the left, the slope? Like the, we got M?
M? Yeah. It's okay. M is the slope of the line. X1 comma Y1 is a point on the line. So with slope-intercept form, we had M is the slope, B is the y-intercept. If I know M and B, I just plug them in. Same thing here. But instead of B, I'm plugging in a point on the line. So I'm going to be plugging in the M, an X value, and a Y value. Sounds a little weird, but it's actually not that bad. Okay. Let's say I've got some kind of line with a slope of 3 through the point 2, comma 5. Got a slope of 3 through the point 2, comma 5. Familiar to what we've been seeing.
Oh, that's screw. I thought that was.
Right? If we were going to write something in slope-intercept form and we would need to find the intercept, this is where we would plug in 5 equals 3 times 2 plus b, and then solve for b. But we don't have to do that here. All we need is the slope and a point on the line. Do we have the slope?
Yes.
Yeah, what's the slope?
3.
Okay, do we have a point on the line?
Yes.
Yeah, what's the point on the line?
2, 5.
2 comma 5. Which of those numbers is my x coordinate?
2.
2. I'm going to call that x1. And what can I call 5? y1. What can I call 3? M. Yeah.
X2 or X1?
Say that one more time.
Is 2 X2 or X1?
X1. There's only one point here, so there's not going to be an x2, y2. We will get to that, though.
Because like you wrote X2. So I'm
Right here?
Yeah.
It says x1.
I think we did that.
Does that look like a 2, kind of? I'll make it more like a 1, then. There we go. X1, Y1. Okay? So I'm going to take the formula that I just wrote above, and I'm going to substitute out all the little colorful letters. So my y minus stays the same. What am I going to plug in for y1?
5.
Okay. Everybody with me so far?
Yes.
Equals, what's my m?
3.
Okay. times the quantity of x minus, what's my x1? 2. And there's my equation in point slope form. Now, point slope form, you may be wondering, like, why do we need to write it a different way? This is more heavily focused on in, like, upper level math, like calculus and stuff, when you're trying to find, like a line that's, like, tangent to a point on a sphere or something like that. I don't know. Something way out there that we don't need to worry about. We just need to worry about the easy thing, which is how to write it. So we take the m, we take the point, we plug in our 3 little pieces, boom, that's what we got. Okay, and if we're reading this, we know, okay, my slope is 3, and I'm going through the point 2, 5, right? Because there's minus signs in my formula, when I see this, it's not -2, -5, it's just 2, 5. Okay? How does that sound so far? Okay? Interesting? I don't know about interesting. Hopefully. Let's try another example. Let's say we've got line through the points -3, 1 and +1, 9. What are the 2 things we need to write this equation again? We need a point and the slope. Do we have a point?
Yes.
Yeah, we have 2 choices even. Do we have the slope?
No.
No. So what do we have to do?
Slope and
Find the slope by using,
y2 minus y1 over x2 minus.
that's right, the slope formula. M is equal to y2 minus y1 over x2 minus x1. What can I label -3, 1?
X1 and y1.
We can call it x1, y1. What can I call 1, 9?
X2 and
x2 and y2. So when I plug everything in, what does the top of my fraction look like?
9 minus
9
1.
minus 1. And the bottom is 1 minus -3. I'm going to take a moment right there, just to pause. Solve that out real quick. Find your m. What do we get on the top? What's 9 minus 1? 8.
2.
What?
What do we get on the bottom? What's 1 minus -3?
4.
4. Aaron, what's 8 divided by 4? Great job. There's my slope. Am I going to plug it in to find b now?
No.
No, I don't care about b.
We don't need b.
I don't need b. All I need is my slope and a point. Do I have a point on the line? I've got 2 of them. Which one do you want to pick? The first one or the second one?
The first one.
X1.
X1 and y1.
The first one, because it's x1 and y1. What if I had written this point first, and that was x1, y1?
That would be incorrect.
Would it be incorrect?
No.
No.
We both.
They're both points on the line. It doesn't matter which point you pick. So we actually have 2 possible answers here. Let's take a look. Let's say I've got y minus y1, which is 1, equals m, which is 2, times x minus x1, which is -3.
Oh, shoot. I thought it was minus.
Is there anything I can do to simplify this equation?
Yeah.
Yeah, what can I do?
To make
negatives in x minus negative 3 to the positive.
That's right. These two negatives here are going to come together and make a positive. So I've got y minus 1 equals 2 times x plus 3. That's it.
That's super distributed.
Or I could have written y minus 9 equals 2 times x minus 1. How did I get that second equation? What did I do?
Let's use the second.
I just used the other point. Okay, now check this out. All right, we've got these two equations. Okay, I'm going to write them up on the board just so I don't forget them. Because I'm going to show you why this doesn't matter. Not the lesson itself, but why what point we use doesn't matter. So we got option A, we got option B. Anybody still writing that? Okay. So, let's say we wanted to convert to slope-intercept form. What does slope-intercept form look like again? Y equals mx plus b. That's right. So I'm going to take option A. Option A was y minus 1 equals 2 times x plus 3. And then after that, I'm going to take option B. Y minus 9 equals 2 times x minus 1. Take a moment and set that up.
How many lines would this example take?
Okay. If I want to put it in slope-intercept form, what variable needs to be isolated?
Y.
Y. Is y isolated right here? No. What can I do to isolate y?
You could add one.
I could add 1 to both sides. But this side over here is a little bit messy. Right? I got to clean that up first. How can I clean that up?
Distribute both.
By distributing.
So 2x plus 6.
3.
Good. When we distribute, the left side stays the same. The right side, as Aaron just said, becomes 2x plus 6. Because we multiplied the 2 times the x to get 2x. Multiply the 2 by the 3 to get 6. Okay, now what did we say I can do to get y by itself?
Plus
Add
1 to
one.
both sides.
Add 1. Add 1. And I'm left with y is equal to 2x plus 7. There's the same exact equation in slope-intercept form. Nice little two-stepper. Just distribute, and then inverse operate whatever's over there. So what we just did, we distributed, and then we added 1 to both sides. Take a look at option B. Give that a try. See if you can practice your converting from point-slope form into slope-intercept form. Let's see what you get. Good. How are you doing the second one, Tyler, on your own? Okay. Good, Kai. Nice.
Wait, I think
All right. I saw a lot of great work. If you're still working, keep finishing up. If I distribute that 2, turns into 2x minus 2. What do I want to do now? Add 9. What is negative 2 plus 9? 7. So I end up with y is equal to 2x plus 7. Is that the same equation we got from option A? Yeah. So when we're writing something in point slope form, it doesn't matter which point we pick. Okay, they're technically both correct.
I just realized they're both the same answer.
Yeah, it should be the same answer. Even though we started with very different equations, because those 2 points are on the same line, everything works out how it's supposed to work out. All right? Questions I can answer about that? Yeah. Sure. Go ahead. All right. Let's go ahead and get started on B12.